So, hello, and welcome back once again. So, today, um, there's this article that I did find when I was doing my research here and there, especially on machine learning, and especially why machine learning projects, tend to fail. Why most of ML models do not reach production. So it's something, if you're working, especially if you're working in the machine learning field. So maybe you can just go through it, then uh, give my opinion based on what this article says. Okay? Based on my experience, especially handling such models, and so and uh, some of the strategies that we can or you can also employ, so that you make sure that whatever project you're working on, you're able to build the same until production. Because again, when you're building these systems, um, the end result the end result should be that your models get deployed, so that the end user is able to use them. Okay, so let's see what are some of the challenges that we tend to face when it comes to uh, ML systems, especially uh, why we don't get to production. Okay, so this is it's just an article. I'll share the link to the article so that you can also have a look at it. Okay, so um, uh, so this is just the failure rates. So this is about the author of this article, and these are just some of the statistics to back the claim as to why these projects do not reach production. Okay, and so I think we can start from this section. So the life cycle of machine learning projects. So I think if you've handled ML models, essentially, yeah, I can use this as a description as to of the a typical ML model. So essentially, you will start with a business goal, because you're building this model to solve a problem. So whatever solution you're going to offer, be it in machine learning, any field within AI systems, you have to start with the business goal, or otherwise the objective. So you need to have an objective that you're trying to work around or try to solve. So there's a problem that you need to solve. Then once you have defined your business objective, the next thing is about the machine learning problem you're trying to frame. So you have to take the problem and try to frame it as a machine learning problem, the way we tend to understand machine learning problems. Okay, so what will be your data? So that will be now the data exploration and processing phase. So what is your data? What is your target variable that you're trying to? What is your target variable, and what are your input features? So input features. So those are the factors. Those are the independent. Those are the independent variables that have an effect on the target variable. Okay, so that's your data exploration. So you have to define that. What's your target variable, and what are the input features? Okay. Then once you're able to do the data processing and also the data exploration, you've come up with your various. Uh, you've come up with your various features. Then the next thing will be about the building the model itself. So you build a model using the data, and then once you're done with the model, you've ensured that they are meeting the standards. So the evaluation model evals. Then you have seen that the model evals are okay. Then you can do the model deployment. So you deploy the model in production. Then in production, after the model deployment, I think you need to do the monitoring first. So once you deploy the model, so that's just half of the process. Now you need to do the model monitoring in production. where you have to check for things like concept drift, data drift, and all that. Okay, so I should say that in the ML field, if you're going to build machine learning models, or if you're going to base your decision on machine learning models, I usually consider it as a dogma. Once you are in, then it's very hard to leave unless you do away with everything. So monitoring becomes this key critical aspect for the machine learning models, because when you're building this model, you're training your model on historical data. Okay, but once you deploy the model, environment can change. The environment can change, and so you actually need to stay on top of that. So you need to ensure you're monitoring. And once, even if you're monitoring, then you need, are you still maintaining within the business goal, or the business goal? If the business goal has changed, are you also changing with respect to that? So essentially, that's a simple workflow of the life cycle of a machine learning project. Okay. So there are two important points in this iterative cycle. So the one is it's lengthy. It's a multi-step process, as I have explained. Then in most advanced cases, it involves numerous cross-team platforms, each having a different understanding of how the model. Okay, so there's a difference. There's a different understanding data scientists will have when it comes to building a model. And let's say you are your supervisor, who is not a data scientist, maybe they are more business centric, so they will have a different perspective about the model. And so, having these numerous cross teams, if they are not in sync, then there is a increased chance that the overall project will collapse based on that. Then also another thing is that the ML projects are data intensive, data centric. ML projects are data centric optimization problems. So feedback signals from data models and monitoring are equally essential for successful outcome. Okay, so I've talked about the monitoring, which is very key because essentially you're building a model to solve a particular goal or objective problem. Okay, if the problem is changing, you also need to look at how your model should change according to the business goal. That's why I said this is more of some sort of a dogma. Okay, so let's look at the pitfalls. So pitfall number one, tackling the wrong problem. So I think this is usually a challenge. Let's say from the get go, if you're going to if the lack of clarity is common, it's a common battle ML engineers fight over before committing to a project. Yeah, because remember, if you're not solving the required problem from the get go, then it doesn't matter how your model is successful in doing the predictions. You're solving you're solving the irrelevant problem. So you need to understand what problem you're solving from the get go, and that's why we have the business goal. So you need to sit with the business minded guys, for example, where the problem is actually emerging from. So you need to sit with them, understand the challenge from their perspective and not your perspective. Then understand what needs to be solved, what can be solved with the model, because again, not every problem needs to be solved by an ML model. Some problems are logical problems. They can just be solved by logical statements or conditional statements and so on. So not everything requires a machine learning problem. So you need to sit with them, understand the problem from their side. Then from there, you're able to draw the map from their side of understanding to an ML a problem. So iterating over business goal and varying with the iterating over business goals and varying with some ambiguity to start. Okay, so uh, so again, once you make sure it's a machine learning issue, you need to frame it as a machine learning problem. So once you have understood the problems from their side, then you can frame it into a machine learning problem. Okay, so this will involve identifying the specific data to extract signals. That's the data engineering part of it. So understanding the data that they have, understanding Yeah, essentially the data that they have, then you're able to map things like the infrastructure, data infrastructure, and all that. So you need to have that from the get go, so that essentially what we usually say is that you need to have the end in mind. So once you have data understanding, quantity of the data, volume of the data, is it clean data, well organized, and so on? Does it represent the business side of things? Or okay, so those are the some of the things that you need to look into. So at the end of the day, we are trying to optimize a mathematically defined objective function. So this objective function is highly dependent on what type of business goals that you're trying to solve. Okay, so let's changes to business goals require adjustments of the data. Okay, because you're optimizing for a particular objective. If the objective changes, that means your data has to also change. That means, again, monitoring is very important. You need to understand what problem you're solving so that you're able to align the data to the problem that you're trying to solve. Okay, so I think that's the problem. Pitfall number one: tackling the wrong problem from the get go. So you need to align uh, the business, the objective that you're trying to solve. And then you need to understand that, do you have enough data to solve that problem? And also, is the problem worthy to be solved using a machine learning model, or it's just a problem that needs conditional statements? Okay, so you need to have that basis in mind before you start building the machine learning project. Okay? So I think this is what the author is talking about. So you cannot build a machine learning model just because the other teams are doing it. Okay, the best ML project. Um, so you have to be pull a stakeholder. Then it has to be solving a business problem. Then it has to be technically solvable. So is it feasible? Okay, is it profitable? Are you creating value? Are you adding value on what is already existing? Okay, so that's what we need to look into when you're building this model. So you need to understand the problem and if you're solving the right problem from the get go. So I think this is the famous analogy if you're running a race. So is it speed or a direction that is most important? Okay, uh, speed or direction. Okay, so you have to consider that. So pitfall number two is about the data. So now that we have understood the problem, now let's look into the data. So the second pitfall is the challenge posed by data. This is one of the most common pitfalls of ML projects, and perhaps the one that your team complains mostly about. Okay? So you're building systems based on the underlying data, and if your data is wrong from the get-go, if it's disorganized, if your data is not does not represent, what can I say, is not representative of the problem that you're trying to solve, then it becomes a challenge from the get go. So there's this famous quote, I think most of you have heard: the garbage in, garbage out problem. So machine learning projects, they depend entirely on recognizing patterns. And if data is flawed from the get-go, then it's highly likely that the conclusion you're going to build from that won't be trusted. Okay, so there's one thing that I actually learned when you're building these models, and the challenge that we actually faced was that, uh, for example, you're using a random forest model or a XG boost, light boost, whatever. See, these models do not understand your data. Okay, they only consume the data that you're feeding them. And so, if you're going to feed them incorrect data, the models won't be there to correct you, telling you that, hey, you are feeding wrong data. Them is just to consume and give you the output. And so, if you're going to work with data that does not meet the standard, then you're going to get conclusions that again will be inconclusive and won't be trusted. And this is worst case, essentially, if you're building a data centric application. Okay, so um, so I think that's the data Problem number two is it's about the data. So you need to ensure that you are cleaning your data and all that. Again, this is usually the most strenuous process. So in most projects, you tend to spend a lot of time doing the data cleaning process, aligning, ensuring that the logic is sound with your data. So those confirmation tests on your data, the validation checks. Okay, so that's usually strenuous. That we tend to spend a lot of time working on that, and so again, it's strenuous, yes, but again, it saves you time, money, resources when you're working on these projects because even if you're going to postpone that problem, it's going to bite you at the end. Then the worst thing is that you're going to go back to clean your data. So it's better to start from the get go, ensuring that you have clean data that is validated. So that means the checks and all that, everything is okay from the get go. So your data has to be clean from the get go before you even touch your model, before you even select your random forest XGBoost, before you even select the model that you're going to use. You need to make sure that your data is clean. Otherwise, you're going to have it rough once you complete your project, only to realize that your data is cannot be trusted. Okay, so so I think this is just an image about so data preparation works. So this is data preparation usually feels like exploring an iceberg. So what you see on the surface is just the beginning. Many problems, especially the ones related to your own data, are hidden beneath. Large organizations also face the problem of data silos. Teams may not know all available features, leading to false unsolvable conclusion. So this is a challenge because I don't think you're able to sit somewhere and be handed data from a central, like being to be handed data. Okay, this is the data that we have. Work with it. Sometimes it's in very rare or very rare occasions, you're able to get data, clean data that you're going to just start to work with. So you have to, again, the problem of silos is a challenge. You have to, data is disorganized between different departments, and especially if you're solving a problem that is cross departmental. Let's say finance team plus, let's say a credit team. Okay, finance team can have a different perspective or a different view about the data. Credit team might also have the same. They can be storing separate data, and so how are you able to collect data from both departments and work with that? Okay, so this is also a challenge that you need to look into. Okay, so that's pitfall number 2. That's about data. Again, essentially, data is usually disorganized in most cases, unless if you have found organizations that they were organizing data centrally, or they had a central location where all data was stored and it was stored in a clean format. Either way, in most cases, data will be in silos, disorganized. So it's your task to ensure that you are collecting that data in an appropriate manner, organizing it, let's say sequentially, proving the logic and all that. So that's another thing, the data pitfalls. One of the major problems that that will make your projects not get to production. Okay? Yeah. So another challenge number 3. So that's pitfall number 3. That's the from model to product. Again, this is think this is the famous Google's famous diagram. I think there was an article written on this about the technical debt in machine learning systems, and this is one of the also a challenge while when I was venturing into the machine learning system, machine learning domain or field. And so one challenge was when you're building, especially during the earlier phases when you are learning machine learning and you're building those models on your Jupyter notebook. So it was quite fun. It was enjoyable, but only to realize that that is not the end process, because your models being on a Jupyter notebook does not entail that it's going to be it's going to solve the problem. No, models being in Jupyter notebook, in some case they can be useless, because what are they? Yeah, you can have good models in Jupyter notebook, but if the end user cannot have access to the models, then it becomes not something to brag about that you've solved. So you have to take your model from a Jupyter notebook and we'll try to deploy those models to production. So that means you are taking from Jupyter notebook to deploy it into production server so that the end user can have a look at it. So once I started to venture into that process, then I came to realize that the machine learning code is just as not even half, a third maybe of the entire process, because you have the configuration, the pipelines, the serving infrastructure, process management tools. Okay, so the surrounding infrastructure that surrounds the surrounding infrastructure that will be surrounding the ML code, it becomes a little bit hectic, and that's how with me I started to have a shift in mindset, meaning that you have to convert, or you have to change from being a machine learning engineer, data scientist, machine learning, to now think like a software developer. So how can you wrap these configuration details, monitoring tools, process management, all that? How are you able to wrap all that infrastructure on top of the ML model that you're building? And so I think if you've read that article, I think this is it. Let me see. Yeah, the hidden technical debt when it comes to machine learning system. It's a nice paper that I think you should also have a look at it, read it, so that you're able to understand machine learning is not just a Jupyter notebook. Okay, so I think this is a typical example. So to get a sense of the gap between machine learning model and a full machine learning powered solution beyond what MLOps alone can cover, let's take retrieval augmented generation system, or in most cases, people will be talking about the agentic systems. Okay, so RAG extracts relevant information from your database, then it provides it, then sends this information to your large language model, allowing the model to answer questions with the exact context in mind. Okay, so a quick demo will look deceptively simple. So an LLM API wrapper, a vector database, and a little bit of orchestration, and you'll be getting your responses. But if you're going to deploy a RAG system in production, that changes. Okay, because you need to have different people need to have access to different information, so you have to also check on that. Then for that setup again, latency, caching for responses, inference tweaks, privacy, fairness, security checks will now have to creep in. And so that becomes a problem if you're building such a system. So there's a hidden technical debt. So it's not just a Jupyter notebook file, but if you're going to deploy these systems, then you need to also consider that. And so then you need to have capacity for you to take a model from a Jupyter notebook file to a fully fledged model deployed so that the end user can use it. Okay? Pitfall number 4, and actually this is something that I'm even currently trying to solve. It's not something that I was preview of. So the offline and the online type of deployment. Okay, so the fourth pitfall is offline access and online failure. So this pitfall is probably the one that causes the most emotional waves with the team. Why do solid offline models fail online? Because data, solutions, and metrics differ between the two stages. Okay, so this is a typical example showing you how to serve model in for real time processes and for offline. Okay, so there is a stark difference between these two, and this is based on this. There's a tool I actually came across too. It's called a Feast. Feast. Is it? Yeah, I think it's this one. Supposed to be Feast feature store. I think it's this one. Yeah, Feast feature store. So it's something that I'm currently also implementing. Once in most cases I was working on batch processing, so that means most of the cases were what is it? Most cases were offline. Then there was a use case that I had to work on a real time data. Okay, so that's also another challenge because um, uh, because of the infrastructure and other requirements that will be needed for this. And so that's also another challenge that faces machine learning teams if you're building these systems. Okay, so you also need to check for this, and you need to guide yourself or set yourself psychologically that if you're going to build a real-time ML solution, what should you have, or what should you consider, or if you're going to build an offline solution for that. Okay, so pitfall number 5. So that's the non-technical obstacles. Yeah, this is also another challenge, especially for organizations that are trying to implement AI solutions. There's a stark difference. There's and is it black and white, or there's a gray zone? Don't fathom that. So the last pitfall often overlooked is related to unseen non-technical obstacles. Okay, so this is also another challenge because decision makers sometimes are unwilling to approve the changes to the existing operations. This is quite a challenge, and it involves rigorous trainings that you have to teach the non-technical staff. Also, because it's a new thing, they can be that skeptical. So it takes time to convince them that okay, this is a machine learning model. This is how it's going to ease your task. I think with this one, the model explainability becomes something that you can look into. It's an easier way to try and help you solve this problem because if you're going to make predictions, at least someone should be able to explain how the model is making predictions. Okay. Lack of sufficient proactive planning. Again, this is a problem. Especially if you're working, if they are doing incorporations and all that. Lack of understanding of proper way to execute deployments. Okay, so are you building an online real-time prediction model or offline? Okay, problems with the availability of the data. Okay, so if your data is not well structured, that's a problem. No assigned person to steward the deployment. Again, this is also another issue because sometimes people think that okay, if you're going to build an AI solution, then we can go to Maldives and have a vacation because the AI systems will be solving the problems for us. There's still some monitoring, and if you're not going to have as a desk that will be if you're not going to set up a desk within your organization, and the person sitting on that desk should be working or maintaining these systems, then it's going to be a challenge. Okay, so I think that is the cost that some organizations tend to look into and say, no, you're not going to deploy this solution because there's that debt that there's that process sometimes that if you have not planned well, then you're going to have a problem. Staff unwilling or unable to work with the model output effectively, technical hurdles, privacy and legal issues, model performance not considered strong enough by decision makers. So these are some of the things that, especially the crisscross the technical side and the non-tech side. So if you're not having a good rapport, then you're going to face these challenges. And if they're quite problematic, then it becomes hard for you to deploy these models. Okay. So yeah, I think that was pitfall number 5. There's also okay. So while there's no guarantee we will avoid all mistakes, there are some principles or best practices we might consider in reality. So we want to choose a problem that is feasible, desirable, and profitable from the get-go. So it has to be a pain point that is really important that needs us to solve. Then we want to be data-centric. That means working with the clean data from the get-go. Furthermore, we want to encourage early collaboration and active management across functional teams. This one, for this challenge, what I usually do, I avoid to build the model end to end and then try to incorporate the management team. But once you're building these solutions, if you make a step or a phase, try to loop them in. Try to tell them this is what you have solved so far. This is what you have solved so far. And they're able to track that progress. So they're able to see, starting with inconclusive data that is disorganized. Then if they see that you solved the problem of disorganized data, let's say you've created a nice repository for your data, they're able to see that difference. And once they're able to track the phases step by step, then it becomes easier for them to see the value that you're creating. Okay. So we want to build end-to-end solutions quickly for testing purposes. So we want to adapt your project management plan based on the nature of the machine learning project. I think this is what I've elucidated, that you need to keep your, especially the cross-functional teams, you need to keep them in the loop so that they're able to track a different progress. Okay. So yeah, I think that's it. I think this is the author. So you can, I'll attach this link so that you're able to also read through and understand the challenges that you'll be facing if you're going to build ML models and deploy them. Okay. So I think that's it. So today was just about having a small talk about machine learning projects and why they fail to reach production. So these and many other, we'll be having these just a small discussion about different topics in machine learning and AI in general. So if you have any topic that you want me to talk about, maybe do some research and have, let's say, give my own opinion, then you can get to the comment section. Let me hear from you from that. Then I'll try to look into. So I think the next one we can look into is the I'll can try to go through this paper, the hidden technical debt in machine learning, maybe in the next iteration. Okay. So until next time, see you. So if you're new, please consider subscribing to the channel. Share with your friends, colleagues. Then until next time, see ya.